All right, good afternoon, ladies and gentlemen, students and friends. So, my name is Wei Jiawen, the Dean of Function Hub at HKUST Guangzhou. So, let me briefly introduce our Function Hub. So, the HKUST Guangzhou actually include four, hubs and 16 thrusts, which is not different from traditional university, where we call it school and the department. But here we call it hub and the thrust. So the vision of function hub, so our hub's vision is to unlock the potential of basic elements in hard and natural science and seek advanced and sustainable solution to address real-world problems. So that benefit mankind and they advances our humanity. So actually a function hub, So function hub is academic structures including four thrusts, including advanced materials, Earth, ocean, and atmosphere science, and microelectronics, and sustainable energy, and the environment. So function hub actually is focusing on the hard science relevant to the early cross-disciplinary research activities. So the detail of the thrust research and activities will be given by the following professors. So our people. So right now, so we have 75 faculty members, including more than 56 regular faculties from worldwide, and we have other 19 affiliate professor, adjunct professor, and professor of practice, which come from the industry and other university and institute. So our 100% regular faculty members with PhD degree from the top universities. So the right hand is including advanced materials. We have thrust head is Ping Gao, who is come from the Clearwater Bay campus. So other three faculties actually all of them from the senior people from the different universities. So here's our young faculty members. They are from different university and graduate from top university from worldwide. So it's our fact hub. Our faculty is actually from the graduate from different university, most from Europe and North America, Asian, and Australia. So some of them are actually working in a different university for many times before come to our university. So our student, but right now we have more than 265 students. The PhD is more than 200. And I have some exchange students from different universities worldwide. So 54% from project we cut a top university in mainland, and actually 100% from QS top 50 institution. So their education background include different research areas. Someone from the physics department and chemistry, environmental, engineering, material science, microelectronics. So whatever your background is different from research areas, but you can fit your research topics. So here you can see from this slide, so our graduate students from Imperial College, Peking University, Zhejiang University, Northern US, and then National Singapore University, some from US, on Puerto University, New York University, and so on. So here, I'm going to introduce the central research facility. So as a PhD and MF student, you have to do some experiment. So in our university, I have established very good, research facilities. We call it central labs. So this lab, all those labs are shared by the HKUST Guangzhou and HKUST Korea Waterway campus. So you can online book all this facility equipment. So this central facility includes material science and nano fabrication. And also you have bioscience and wave function materials. So except this central facility, but also some of the same-based labs. So this same-based lab is initiated by our fact members. So these labs include all these research areas. So you can complicate all your experiments here in our campus. So it's very easy to do an experiment, and then you can do whatever you want. So I'm going to give some application tips. That's because right now you can online apply send your applications. So the first one, you have to complete your English language test as early as possible. That because it's a very required condition for entering this university. So as soon as possible, you have to complete your English test. Next, you have to prepare your application materials. That's very important. You have to submit your application forms as soon as possible. And third one, you have contacted your potential supervisor via email or phone call. That's very important for you. You can call your professor and the potential professor, and you can discuss your academic. You can discuss your topic, and you can show your academic ability and the potential in your personal statement. That's why, because your personal statement is very important. So your supervisor can maybe understand what you want to do and what you able to do. It's very important. So please complete all your research statement very carefully. So it's welcome to Function Hub, and all the detailed description of thrust will be given by the following professor. Thank you very much.
Hi, everyone. So welcome to our online information session on PhD study in functional material of HKUST Guangzhou. I am an assistant professor from Advanced Materials Trust, and I'm very delighted to be here to introduce our program to you. So given the time limitation, I will focus on a brief introduction to the program overview, our current research themes that may be related to your potential research direction in the future, our faculty members who may become your future advisor, and our resource. Among the programs and the subjects that you may see in the campus and all over the world, you may think about. So why to choose the program of advanced materials? So one short answer from me is that the abilities and of scientists and engineers that you may be in the future are how we can control atoms come together and using that knowledge to create new materials. The world will change. This opens the door to the modern advanced material science and engineering and becomes the foundation of other future technologies. So that brings our version of advanced materials trust is to be a world-leading research institution and educational program that aims discovery and innovate new and sustainable material with strong social impact. To achieve that, we should rigorously explore the fundamental material structure and property relationships to unlock the potential of basic elements of natural science for conducting cutting-edge research for material discovery and innovation. To make that happen, we devote to cultivate and nurture future scientists and engineers, and also the leaders with academic excellence, broad enough education, competencies, leadership and teamwork, international view, orientation to the future, and with strong ethical standards and compassion to the community. For PhD candidates, you are required to complete 21 credits for a total PhD program, including 15 credits for domain knowledge. So here, AMAT offers multidisciplinary domain knowledge elective courses, primarily covers the fundamentals from material science and engineering, physics, computational science, and chemistry. Students are given the flexibility to choose a domain knowledge course that may be relevant to your future research topics. So currently, AMAT is interested in 3 major cross-disciplinary research areas. They are soft matter, quantum matter, and AI matter. Each research area has different research topics, like functional polymer material, polymer upcycling, flexible electronics, energy material, and bioengineering, biomedical materials in soft matter, and quantum material and quantum chips, quantum optics and computation, quantum software, and quantum metamaterial in quantum matter. We also have material informatics, AI for energy material design and processing, AI for biomedical materials, AI for quantum materials in AI matter. So different research teams that led by different professors are engaged in these 3 different research areas. So currently the AMAT has 14 onboard full-time faculty members with different expertise. Who can be your future PhD supervisor or advisor? Here, Professor Zhang Tongyi, so his current research interests are focused on material informatics. Professor Wen Weijia, so he's working on discovery and develop wave functional materials. Professor Gao Ping, she specialized in rheology, and she is leading the world-class polymer nanomembranes research. We also have a few assistant professors. Professor Chen Peng, so he is focused on experimental quantum information science. Professor Chu Xiakun, he is an expert in computational biophysics. Professor Gan Zhechen, he is a mathematician and interested in materials scientific computing. Professor Huang Yang, so his research mainly focuses on the synthesis and the regulation of energy-related materials. Professor Li Haoxiang, so he interested in study quantum materials using advanced spatial resolved spectroscopy. Professor Liu Jingguo, he is specialized in quantum computing. Professor Chikiam Tan, he is interested in semiconductor material, in particular the wide bandgap material like gallium oxide. Professor Wang Jun, he is an expert in functional polymer and nanocomposites. Professor Jia Yingwu, who is specialized in photophysics and device physics using time-resolved ultra-fast spectroscopies. Professor Wu Xiaoxiao, he is an expert in metamaterial and wave matter interactions. Professor Yuan Rongfeng, his research focuses on energy transport mechanism of optoelectronic materials and molecular dynamics of complex liquid systems. So to conduct interdisciplinary research, the AMAT has 3 STEAM-based labs that are commissioned. So first is the Green E-Materials Lab. This is a research center that focuses on enabling green materials technology by cross-disciplinary expertise in electro-optics, energy, enzyme, and elemental control. So the next is Quantum Science Technology Center. Through the name, you can imagine that this center is focused on quantum materials, quantum optics, atomic physics, and quantum information to develop new quantum technologies. And these two labs are has an area of over 1,000 meters square and are facilitated with the cutting-edge research equipment. And we also have a material informatics lab, which conducts AI-related material research. Apart from the theme-based labs, we also heavily access our university levels of central research facilities. For example, we have a top-of-the-line X-ray related acquisition in MCPF, and also the largest university chip fabrication line in NFF and other central facilities. Externally, we have a networking across the world academic and also industry partners all over the world. So here is our some admission information. I think you may know, and for detailed information, you can scan the QR code for more information. And one note is that, okay, in terms of the full-time PhD program, if you have the related MPhil or equivalent degree, the program length is about 3 years. And if you have no related MPhil degree, then the program is 4 years. Part-time is 6 years. So lastly, I would like to share with you the experience in material research. So of course, the learning curve in this area is usually very steep, and the major breakthrough appears when you put enough effort. So in here, AMAT, we do need to work very hard. And thank you for your time, and wishing you all the best for a success in future work and a happy life. Thank you.
Thank you everyone for joining our introduction session. I'm Liu Qianyu, an assistant professor from the Earth, Ocean, and Atmospheric Sciences. I'll introduce you with a bit more information about what I work later when I'm introducing our paper. Okay, so well, our STRASS has a really long name compared to others. So what do we study? Essentially, well, we here study how the planet Earth works. So the Earth system is a complex system. It consists of land, atmosphere, and the hydrosphere, including the ocean, river, and lakes, as well as the biosphere, such as the marine ecosystems, as well as those terrestrial ecosystems that we are more familiar with. So this is a complex system, and those components, they are exchanged with each other through those material cycling and energy flow. So because of this interlinked nature, people in the Earth, Ocean, Atmospheric Sciences STRASS work on really interdisciplinary research topics. Although each of us mainly focus on one component particularly, but together we share the goal of better understanding how our planet, the Earth, works, including how it controls the climate and how the system is going to change under the future, as well as how we human beings can better prepare and respond to this kind of changes. And particularly, we work on these 5 research areas. So this is each of them is a really grand branch, including the atmospheric science, oceanography, Earth urban system science, and Earth surface process, as well as climate adaptation and resilience. And under each branch, we have many small subdisciplines. And it's a very long list, but you can also check our website for the details of these disciplines, including the corresponding advisors. And how do we study these complex systems like the Earth? So first, we rely on those lab instruments from the central facilities like the Sustainable Atmospheric Environment Research Facility, which we already have. So it includes a lot of indoor environment and energy instruments listed here. In addition, it has those outdoor observation stations. So for example, this one is located on the top of a library, which is monitoring the meteorological conditions in real time. And since we are also interested in the land surface process as well as the ocean research, so we also have a lab called the Earth and Environmental System Research Facility. It increased with advanced analytical systems to analyze those chemical samples. In addition, we have this is a retired buoy system used to stay in the ocean to monitor the water temperature, salinity, and other interesting biological and chemical properties in real time. And in addition, we conducted a cruise at sea to collect water samples and to monitor those biology and food web dynamics in the water when we collect the water samples to measure them on the sea. In addition, we also have a group of people working on the river basin. So this is also this picture actually showed our students collecting water samples from the Pearl River last summer. And as we mentioned that we understand the Earth system, this is really complex. So in addition to observations, we rely a lot on doing model simulations. And for this kind of large-scale model simulations, we rely on a high-performance computing system. So in our university, we already equipped with high-performance computing system integrated with the artificial intelligence. So with these platforms, we are ready to submit our model simulations through this in-home equipped high-performance computing power. And so who we are, we currently have 9 faculty members, although we are small, but we are working on different perspectives of the Earth system, and we are still actively hiring faculty members. So stay in tune, we will have more faculty members joining us this fall. And so I'll introduce a bit more in detail of each faculty member. So firstly, our acting head, Professor Shunchen Li. He's a well-accomplished scholar. His main research interests rely on the indoor and outdoor air pollution and the associated health impacts. He's also interested in those technology that can mitigate these air pollution problems. And we also have atmospheric sciences, Dr. Zheng Liu. He's looking at larger scale dynamics like the Asian monsoon and the climate change. His research interests include the air thaw and monsoon climate interactions, the extreme weather and climate events, the regional impacts of climate change, as well as system modeling. And his primary tools include those large-scale system modeling, as well as regional-scale atmospheric models. We also have a newly joined atmospheric scientist, Dr. Yixing Guo. Her research focuses more on the chemistry of the atmosphere. So she's interested in the nitrogen cycle and atmospheric environment, including the emissions and Earth system impacts of reactive nitrogen. And she's particularly interested in how we can mitigate this kind of emissions through some management of agriculture. And we also have Dr. Jingshu Qi, a biometeorologist. So she's looking at the interface between the atmosphere and biology, particularly at the terrestrial carbon and water cycles, the land-atmosphere interactions. And her primary research tool is through the eddy covariance technique. So here the schematics show many towers that are most equipped with the eddy covariance technique to monitor the carbon and water fluxes from the different ecosystems to the atmosphere. So her team will involve a lot of field trips as shown by this picture. And we also have Dr. Yi Liu. He's a hydrogeologist, and he is interested in the carbon-nitrogen cycle in watershed, as well as those exchange between the river and more invisible groundwater and the submarine groundwater discharge and its environmental impact. And this map shows those stations his team has visited over last summer and winter. So for his team, it also involves a lot of this kind of field trips and sampling. And this is our Dr. Qichen Yang. He's a hydrologist, and his main research tool is through modeling, although he's also interested in those watershed process and the riverine carbon cycling, as well as the effect of this riverine inputs to the aquatic systems. And as the old saying goes, all of those materials will reach the ocean in the end. So we also feature 3 oceanographers. One is Dr. Qing Li. He's more on the physical oceanography side, and he's interested in this small scale process like turbulence and how this small scale process interact with larger scale and then consequently affect our climate. And he's primarily applying those numerical modeling techniques. And he's also interested in how to better improve this or accelerate the computation speeds of this process. And we also have a chemical oceanographer, Dr. Qixing Ji. So he is mainly relying on the isotopes and other chemical analysis to better understand how nitrogen is cycled in the ocean. And that's me. I'm a biogeochemical and ecosystem modeler. So I'm interested in the cycling of this life essential elements, including carbon, nitrogen, oxygen, and phosphorus. And I primarily use models to simulate their effect in the water, as well as how it affects our ecosystem. So as you already probably heard from our introduction earlier, that our PhD program has the advantage of this cross-campus study. And our thrust also have strong connection with like Ocean Science Department and other divisions or School of Science in the Hong Kong campus. So we can offer this kind of cross-campus opportunities. And the requirement of our applications are similar to other slots. So I'm going to skip here, but you are highly encouraged to contact us before your application. And the timeline will be the same as other slots. And the same requirements here. So you can scan our QR code here to get more information regarding the details of these requirements. And yeah, there are more QR codes here for you to get more information for different aspects. And I think that's it.
So hello everyone, my name is Xinyu Chen, Assistant Professor of Microelectronics Trust. Today is my great pleasure to introduce Microelectronics Trust to you. Well, let's get started with the research areas of our trust. Basically, it spans across architecture, circuit and device, EDA, and systems. For architecture, we are broadly interested in general-purpose multi-core processors, FPGAs, memory and cache, storage systems, interconnects, system-on-chips, system-in-package, embedded system, to name a few. And for circuit, we are doing media meter wave IC, T-Hertz IC, electronic and photonic hybrid IC. And also for device, we are interested in new storage device, transmission, computing, quantum device. And for EDA, there are a lot of subdirections like IC design, automation, hardware, software co-design, low power chips or chips thermal design, and so on and so forth. And lastly, for system and application, we are broadly interested in morphic computing, approximate computing, quantum computing, as well as system software, compilation techniques, and operating systems. I think you can find whatever you think of. And those directions are actually supported by our brilliant 28 faculties. You can see their photos here. And I need to emphasize that most of our faculties, or all of our faculties, graduated from top-tier universities like Princeton, Harvard, ETH, TUD, Penn, and GTech, right? And also, interestingly, many of them are have the experience in working in the IC industry, like Samsung, Marvell, Google, Huawei, as well as HiSilicon. In the next, I want to introduce a few colleagues that are joined recently. Yeah, the first one is me because I'm the latest one that joined the department. I graduated from National University of Singapore, and after my graduation, I joined HiSilicon as principal engineering, where I worked on a programmable accelerator for the next generation DPU. And so my research interest lie in hardware accelerator. Basically, we can implement that on FPGA or integrate it with RISC-V processors. It's kind of a domain-specific hardware acceleration. So our target application includes large language models, a vision transformer, graph processing, as well as data analytics. I'm also interested in heterogeneous computing, where we can collaborate CPUs with the heterogeneous resources like GPUs, NPUs, FPGAs for efficient processing. Lastly, system design and optimization is also interesting in current cloud environments. For example, how to design the accelerator disaggregation and how to propose the high performance big data management system with disaggregated resources. You can contact me through the email below. Next, I want to introduce the Professor Yang Ke who is graduated from Penn State, and he is doing neuromorphic computing, like spiking neural networks and spintronic devices, as well as hardware algorithm co-design in both top-bottom and bottom-up manners. You can contact him through the email below. And next, I want to introduce the Professor Liu Xiwen, who is graduated from Penn. His current research lies in nanoelectronics devices, emerging memory techniques, computing in memory, AI accelerator, as well as unconvolutional computing. Again, you can contact him through the email. Lastly, I want to introduce the Professor Cai Guigang, who is from University of Macau. His research interest lies in hybrid DC-DC converters for high efficiency, small volume, and fast response. And he is also doing low dropout regulators, as well as high current density power supply. Yeah, you can contact through the email. Of course, we have many other faculties. I don't have the time to enumerate one by one, but for more information, you can visit the link below or scan the QR code here. Next, I want to introduce our brilliant research facilities to support the aforementioned research directions. Basically, our research facility can support from materials characterization to device manufacturing, IC design, to packaging, and to system design. Well, the first important facility is the Neural IC Exploration Central Facility, abbreviated as NICE. I need to emphasize that this is the only IC research facility in the universities that is supported by professional technical teams. And it has over 3,000 square meters and clean room, constant temperature, and so on and so forth. And in this NICE, we have a complete set of advanced chip design and testing equipments. Also, we have chip design, simulation, analysis softwares, as well as prototyping and testing platforms. As you can see from those figures, they are very advanced and also expensive. The next important facility is Nanosystem Fabrication Facility, which is called NFF. Again, this is the largest and the most advanced nano fabrication facility in global universities supported by professional technical teams. And it has over 6,000 square meters. You can do third or fourth generation semiconductors, silicon photonics, quantum storage, memories, sensors, heterogeneous integration, etc. And also you can have you can do advanced nanoscale optical, electronical, and so on and so forth. Lastly, I want to introduce the materials characterization and preparation facility, which is called MCPF. It's used to support comprehensive analysis of physical and chemical properties of various materials from micro to nanoscales. I'm not going to show the details here. You can refer to more details from our website. Lastly, from the system level, system design level, we have the Center for EDA Research. And it's worth mentioning that we are the Guangzhou EDA K Lab. We can do modeling, simulation, verification, optimization, automation, and methodology in our research center for device circuits and to name a few. And we already open sourced the 16 EDA tools. And our center actually is hosting the IEEE Council on EDA Guangzhou chapter. We also our center also hosts some international organizations and conferences. I will elaborate the details later. And we have partners from like Hong Kong, professors from Hong Kong, and also from US, Europe, Japan, Korea, Singapore. Of course, we have many partners from mainland China. And yeah, we are very actively in hosting international conferences like the Field Programmable Technology 2022 and also the VLSI 2018. We also host some forums like optics and photonics. Lastly, I want to mention about the postgraduate courses. Basically, we have a diverse set of courses that can extend your knowledge and also support your knowledge needed in your research. I'm not going to enumerate one by one, but I think you can find the topic you can think of. To summary, we have a very broad set of research areas, and also we have advanced equipment for research. And we are from the Guangzhou, but we are connecting the world. We have tight collaboration with universities in Hong Kong or Macau. And also we have close communication with international universities and research institutes. Of course, we have industry collaborations, and also we are actively in hosting international conference and forums. Yeah, that's all about the introduction, and thanks for your listening, and welcome you to Guangzhou and to our
Good afternoon,
trust.
everyone. My name is Fang Ting, and I'm from the Sustainable Energy and Environment Trust. I'm very delighted today to introduce our source to you. So our source is called Sustainable Energy and Environment, and short for SEE. So as you can see, the keyword here is energy and environment. So our goal is to tackle global energy and environmental challenges to provide a sustainable and healthy growth of humankind. Our PhD program aims to address global challenges listed here in the middle that include carbon emissions, global warming, energy crisis, green energy, health risk, and air pollution. And our research could be directed into two main streams, energy on the left left-hand side and environment on the right-hand side. So in the energy streams, we investigate how to better harvest, convert, store, distribute, and save energy. Whereas in the environment stream, we study the formation, transformation, transport, distribution, and human exposures to air pollutants such as greenhouse gases and particulate matter. So our overall goal here is to create an environmental friendly energy system and a sustainable living environment for humans. In order to achieve these goals, we utilize the most advanced research methods. And as you can see, in order to tackle these complex issues, our approach must be very cross-disciplinary, drawing on ranging from fundamental sciences such as physics to various energy disciplines, to toxicologies, to exposure science. So if you have a background in any of these areas and are also passionate about addressing these global issues such as us, then I encourage you to consider our program. So I would say one of the most distinctive feature of our program is a cross-disciplinary education and research in the field of sustainable energy and environment, which really sets us apart from most other universities. So in the following slides, I'm going to give you a couple of reasons why you should consider our SEE program. First of all, we are a group of people that are determined to nurture a new generation of professions who can take a cross-disciplinary and holistic view of environment and energy issues and become the global leader. So in order to achieve this, first of all, we design our programs such that the students are trained with cross-disciplinary research methods and design thinking. The student also required to take core courses, and that can broaden their knowledge boundaries, as well as courses on domain knowledge that are more specific and be delivered by our own faculties. And second, as a hard science program, we are aware that equipment are students' weapon. So I'm going to introduce the 4 research facilities available on HKUST GZ campus that provide a total research area about close to 5,000 square meters. So the first one is called the Brilliant Energy Science and Technology Theme-Based Lab, or BEST Lab. So this lab focuses on the development of the next generation sustainable energy system with a low carbon footprint. The lab provides our students with many cutting edge facilities and equipments in solar energy conversion, self-power devices and systems, smart power, electronic exploration and design, and so on and so forth. The next one is called a Bio-Inspired Energy Research Facility, or Bio-IERF, which is a central facility that can serve students for research in bionics, fluid mechanics, and heat transfer. It's equipped with a 3D computer control steam support and force sensor, a wind tunnel, a water tunnel, and a thermal particle imaging velocimetry. The third one here, just now, Professor Yu has introduced this lab. And I'm just gonna add that this central facility include a super site and also an indoor environment and energy lab. Students can get access to many online monitoring and offline analyzing instruments for atmospheric gases and particulate pollutants. And this lab has 4 environmental chambers, which include a smart chamber, a photochemical chamber, 2 environmental test chamber for temperature and humidity, and then another environmental simulation chamber. So the research in this lab mainly will provide students with tours for indoor and outdoor air quality and monitoring and simulation studies. So other than the above mentioned research facilities, here at HKUST GZ, we also have another 13 central research facilities that are open for students to use. And then another 23 theme-based labs that welcome students to use their facilities and equipment. So no matter if you're doing material fabrications, analytical chemistry, cell culturing, etc., or modeling, you'll be able to find facilities that fits your needs. And a lot of these are brand new. Let's move on to academic and industrial collaborations. So our research here have established collaborations with many distinguished universities in China, such as Tsinghua or Peking University, as well as research institutes from in China, Guangzhou, Guangdong, or Sichuan. Other than academia, we also have a close relationship with many industrial leaders, providing opportunity for students to interact with them through research projects that are funded by these companies, such as China Southern Power Grid, UID, and Huawei. We also work with national and local environmental agencies through ongoing projects looking at environmental issues. And the last but not the least, I would like to introduce our faculty members. So far we have 18 full-time faculty members. And all our faculty members have studied or obtained our PhD degrees from abroad. And here we are very happy to share our experiences with our students. And in some cases, our students may have the opportunity to work with peers or scientists from these universities. So other than the full-time faculty members, we also have 11 faculties that are joined with us or affiliated with us. Many are from the CWB campus. So next, I'm going to introduce our professors one by one. Hopefully, you can find one that match your research interests. So first of all, it's our head, Professor Qiu Huihe. He's an expert in fluid dynamics and heat transfer. He studies the bio-inspired flyers and micro-air vehicles, transport phenomena in microscale multi-phase flows, and also sensors and actuators. He also studied the thermal comfort sensing in smart buildings. And then we have Professor Zhang Tongyi, who's an expert in material informatics, material general engineering, and mechanical informatics. And then Professor Li Shunchen, he studies indoor air pollutant, looking at the toxic component. His research group also categorize emission sources and carbonaceous aerosols. Then we have Professor Zheng Junyu, whose research interests are on source characterization and emission inventories. His group looks at co-control air pollution and carbon emissions using novel source measurement instruments and source tracings to look at the sources and the application of big data and AI to environmental models and emission mitigation. Then we have our associate professor, Zi Yunlong. His research interest is on high performance mechanical energy harvesting through triboelectric nanogenerators. He also looked at triple photonics towards novel cell power wireless solutions, the mechanisms, the discharging of these generators, and also look at the flexible and stretchable energy harvesters. And we have Professor Zhou Yuekwan, whose research interests look at zero energy buildings, energy flexible buildings with renewable energy, advanced energy management strategies in batteries and in hydrogen storage, and also looking at latent heat storage and how to optimize for smart buildings using machine learnings. And then we have Professor Han Wei, who studies wireless power transfer, power electronics, electric vehicles, technologies, and electric machinery. And then we have Professor Wang Jiaqiang, who studies battery sensors, electrochemical energy storage, data-driven battery diagnostics, and also applying AI, battery, and sensors together. And then we have Professor Xiao Dianxun, who studies electric vehicles and more electric aircraft, electrical machines and control system, battery management system, optimization and data-driven approaches, estimation and diagnostic algorithms, and etc. Then we have Professor Zhou Teng, who studies the carbon capture and storage using different methods such as direct air capture. He look at process and energy system engineering, energy efficient chemical separations, and waste treatments in these processes. And then we also have Professor Yan Chang, who studies AI for solar cells, new generation of different solar cells, and then also thin field and nanostructure material for solar field production. And myself here, I study atmospheric chemistry and as well as chemical biology, looking at outdoor and indoor aerosols, health-related aerosols, the cell toxicity, and we're specifically looking at long and short-lived free radicals. Then we have Professor Zheng Jian, who studies thermal energy materials and heat transfer, and solar thermal energy conversion and storage, the carbon capture and conversion, as well as these applications in water harvesting and building management. And then we have Professor Zhou Shen, who studies membrane separations, and electric membrane synthesis, metal organic frameworks, and the application of different frameworks in gas separations, carbon captures, and thin film devices. And then we have Professor Liu Chang, who specifically look at smart soft materials and the application of this soft material in low-grade thermal energy harvesting, as well as thermal management. And another one is in water harvesting from the atmosphere. And then we have Professor Liang Yutong, who studies indoor and outdoor air quality using mass spec techniques and low-cost sensors. His research interests mostly focus on biomass burning. Then we have Professor Fang Chao, who studies interfacial science in fluid transport, ion transport, soft matters, and carbon capture storage, and also machine learning for molecular systems. And then lastly, we have Professor Xia Xin, who study also high performance triboelectric nanogenerators and the application of these generators in biomedical systems, etc. All right, so that's all for my introduction for our program and our faculties. You can scan this QR code for more information on our faculty profiles, and I strongly encourage you to contact them if you're interested. Thank you.